Let's talk about graphs of damped and undamped motion. If we have an object with mass m attached to a spring with spring constant k, and the damping constant for the system is b, then the position y of t of the object satisfies the differential equation my double prime plus by prime plus ky equals 0. Now, if b is 0, that means there's no damping. We have undamped motion, and we end up with a graph that looks like this. It's just going to oscillate forever and ever because there's nothing to stop it. If, on the other hand, b squared minus 4mk is greater than 0, in other words, mr squared plus br plus k equals 0 has two different real roots, we're going to end up with motion like this. This is what we call overdamped. It's damped enough. It's called overdamped because it's damped enough so that there's no oscillation. If, on the other hand, b squared minus 4mk is less than 0, mr squared plus br plus k equals 0 has complex roots, that means the motion will be underdamped. So it's not damped enough to stop the oscillation. It will just oscillate forever and ever. Although, again, notice it goes, it gets closer and closer to that equilibrium point. It doesn't oscillate as wildly as it does in the beginning. Now, if b squared minus 4mk equals 0, mr squared plus br plus k equals 0 is going to have a repeated real root, then it's going to be critically damped. We call it critically damped because this is like the Goldilocks point. It's damped just enough so that it doesn't have isolation. If it were damped any less, it would oscillate back and forth.